Okay, well, no, we'll get there later. We don't know that yet. We do, but we don't. All right, in what order do we select the cutting parameters? We have feed rate, depth of cut, and cutting speed. In what order do we select them and why?
I'm not sure if this is right. Would it be cutting speed first, and then feed rate, and then depth of cut?
Okay, yes. Why?
I said because the magnitude of cutting speed in the equation that you gave for tool wear was the highest, and then feed rate was the second highest.
Okay, yeah, so we do cutting speed first because it is the highest effect on things, and feed rate is next, and then we do depth of cut to maximize the amount that we can without running out of horsepower or tool strength. So one of those we will run out of. And the feed rate determines our surface finish based on our cutting speed. So it's always cutting speed, feed rate, and then depth of cut to get good chips. And so we might start cutting and see nasty chips and then change that. What is bad about heat being generated in the cutting process? Okay, you can weld the material to the tool, and then the tool is failed, even though the tool underneath is just fine. But you, in general, cannot break it off or unweld it easily. All right, what else? Yeah.
The localized heat could like make uneven properties in the material, like it could anneal at the surface.
Yeah, it can do that. It can do a little bit of annealing in the surface. In general, it is so fast and so small that you can only really change the heat in the chip. You can't really change the heat in the body of the material to an amount that matters, mostly. You can certainly surface, you can cold work the surface. Yeah.
If the tool is hot, will it wear faster?
Yeah, so the hardness of everything drops off quite a bit as it gets hot. And so if we heat up the tool, the hardness of the tool goes down. And as the hardness of the tool goes down, then we will wear the front face of the tool, and then it won't be the shape we wanted. Yeah?
You can get like crazy warpage in the part.
From heat?
From like thin parts, you know? Not crazy warpage.
I don't.
It can like swell.
I'm not sure it's from heat. You can swell it a little bit and cut too deep, but most of the warping that happens in a part is from releasing residual stresses that are in it from a previous operation. So if it was a rolled part, or if it was just whatever happened last, it may have a lot of residual stress locked in it. But it would be pretty rare to be able to put enough heat in a part to warp it in a machining process. It would have to be very, very thin. What's good about heat in a cutting process?
Softens the material.
It softens the chip specifically. So it softens the chip, helps the chip to just roll around and curl better, so that it will then cool and break. So that is the primary thing that it does. What is wrong with the statement? If we use the highest cutting speed, we can remove material really fast, make a lot of parts, and therefore make a lot of money. Yeah?
Increase heat and the cost problems we talked about.
Okay, like which problems? Which
like the chip loading or reducing tools.
Okay, yeah, so we can reduce the tool life, and if we reduce the tool life enough, then we spend all of our time changing tools or paying for new tools. So tools have gotten pretty expensive recently. Just a normal half-inch end mill used to be between $40 and, I don't know, $80. They're sort of in the same, it depends on whether you get them coated or not. But if you start burning through these things very fast, they get really expensive. The ones that cut honeycomb cost between $250 and $1,200 a piece, and they burn out in about 2 hours. So they have a very short tool life, less than if you were cutting steel of the same thickness. So, anyway, if we're changing tools all the time or burning through tools, we can easily lose more money than we get just by cutting quickly. Any questions about that? Yes?
Why does the honeycomb kill the tool so fast?
Why does honeycomb kill the tool so fast? So, as you are cutting the cell, you can think of a cell like that. As you come through and you cut the cell, typically, because the fiber orientation makes it, in the thin wall, makes it difficult for the honeycomb to be cut. Also, with the fibers, we end up using a highly negative rake angle, so it kind of mushes into that cell. What will happen is, instead of cutting, the cell will start to collapse, and it just keeps rubbing the tool, rubbing the tool, rubbing the tool until it gets all the way to the other side of the cell, which strengthens it a little bit, enough that it'll get cut and the little flaps will come out. But for the entire width of the cell, all it does is rub the tool and create heat. So, yeah, which is why people should use an arc saw. But anyway, we have to get it developed first. But as soon as we do, it's gonna be sweet. An arc saw, yeah. We're making an arc saw down on the other end of the building. We haven't filed our patent yet, but it is so cool.
It's like your bandsaw was an angle grinder.
It won't be on an angle grinder in the future. Anyway, yes, it's gonna save everything.
The
The world.
We should
The
thank.
whole world. All right, here you go. We should understand what an end mill looks like. So, with folks at your table, you should draw an end mill, a side view and an end view. I want you to try to figure out what the rake angle of your end mill is, sort of approximate it. I want you to think about the number of flutes that it has. And you should, I don't know, if you had calipers, that would be great. If you don't, then you can estimate things. I would be, oh, you need another one.
They just say it back.
They are sharp, so don't check to see if they're sharp, unless you check them the right way.
I can do it like this way, right?
You can go across it. One other thing you can do is go across your thumbnail or a fingernail and see if it peels up fingernail. Oh. No, not true to size. Draw it so that you can, well, I mean, you can draw it true to size, but you need to draw it so that you can see detail in it. I want you to try to understand what's going on at the end.
Hey, Alana.